basically have been, some kind of lecture on computational linguistics for a very long time, and especially for net exam and also for their future scope in PhD. So we thought that this would be a great opportunity. Everybody is at home and we can, of course, learn quite a lot during the online series. So that is how we came up with this idea of having an introduction to computational linguistics. And we are very fortunate and we're very happy that Dr. Amalesh Gope is the first speaker of this series, and he has readily accepted to give a talk on this topic. So we are very privileged. With us, we also have, with me and Professor Dhiren Singha, we also have our HOD, Professor S. Ganesh Bhaskaran. I would like to request our HOD sir to kindly give an inaugural speech for the program. Sir, please, you can unmute yourself.
Yeah. Good morning to everyone. I feel privileged to inaugurate this wonderful program. Of course, as Monali told, many of the students do not have much idea on computational linguistics. Although we have a paper, optional paper on computational linguistics, we are not able to clearly make them clear to the students in many of the aspects on computational linguistics. So it is a wonderful opportunity that we are getting experts to deliver lectures on this area of computational linguistics to the students as well as many of the faculties and research scholars and other things. So it will be a very useful program. So I personally thank Professor Dhiren Singha and Manali because of their own initiative. This is going to happen. I also thank other faculties who are behind us to support in different other angles. Anyway, I wish all the best for successful completion or continuation of the program, because many more series of lectures may also come up in the future. Anyway, I wish the speaker, Amalesh Gope, for joining with us. On behalf of the Department of Linguistics, Assam University, we are participating and giving lecture on this computational linguistics. Once again, I thank you, Professor Amalesh Gope, for accepting our invitation. Thank you so much.
Thank you, sir, for. I hope I'm audible. Yeah. Thank you very much, sir, for your so, without further delay, I'd like to request Ruth to kindly proceed with your talk. The duration is 40 minutes, and we will have approximately 10 minutes for the discussion. Thank you.
Working as an assistant professor in the Department of English at Tezpur University. And thank you to the organizers for giving me the opportunity to talk and share some of my research experience. I don't know how much justice I will be able to do because I could see a lot of participants from different.
Hello.
Am I audible?
Yes. I think that was by mistake.
Okay. So in this talk, what I'll do actually, I'll try to have a brief idea about computational linguistics. I'll also talk about the current scenario and the challenges that we face from in Indian languages context. or especially the languages of Northeastern languages. And then the final part is something I don't know how much of interest I will draw, but then I actually try that is in collaboration with some foreign collaborators, where I'll try to link linguistics with biology and physics through AI. So that is actually keeping in mind that the young people who just start their journey into computational linguistics may think of such exciting research in their future. Okay, so I'll just share my screen. You may stop me because if I go for the presentation mode, possibly I may not be able to see you. You may stop me or interrupt me if you have any questions in between as well. Okay, so in today's talk, we'll be discussing about the idea of linguistics and computation. So the current trends and status of languages in terms of computational linguistics, and the importance of computational linguistics and speech technology, and then what are the future research that we can actually look at. Moving forward, I guess all of us understand what linguistics is all about, and I would actually try to quickly remind the students of linguistics which started their journey how you produce language, how do you process it, and how do you perceive the concept or idea. So the moment you have an idea in your mind, okay, so that's your psychological aspects. Once you have the psychological aspect, your brain sends signals to the articulators, to neurons, to produce some sounds that would reflect that idea. Okay. Now, once you release those speech sounds, okay, that would travel via ear, would hit the eardrum of the listener, and then the processing task would start. Okay, so that's the physiological part first. So the receiver would receive the signal, send it to the brain again to decode, and then try to understand the idea that was there in the speaker's mind. This itself is some sort of computation that actually happens in our brain, right? So from that point of view, let us try to roughly define what computational linguistics would be. Okay, so it is a scientific field concerned with the understanding of written and spoken language from a computational perspective. That is, uh, that would try to understand, decode, and conceptualize that would be expressed either through written form or the spoken form. It also tries to develop artifacts that process and produce some form of language. Why did I say some form? Because we are yet to achieve 100%, say for example, success through machine learning algorithms. In some cases, in some languages, you get better results, but then for most of the languages, we don't get. I'll come back to this point in a short while. Computational linguistics also provides an insight into thinking and intelligence. What does it mean is that it tries to understand the process of communication itself. So, for example, the way human mind would work, uh, or the way human being would respond to a particular question. Now, imagine all these tasks would be done by a machine. It also monitors and facilitates human interactions with the machine. Now, you see, I have highlighted these two words, written and spoken language form. Okay, therein lies a sort of challenge. I actually would like to elaborate a bit on it. Language is necessarily oral in nature. Okay, most of the world languages lack a writing system. We must understand that writing just facilitates the visualization of the language, right? So one of the major challenge that computational linguistics or any NLP related task actually face due to the lack of written document, or maybe because it is mostly oral, and the creating some sort of bank like corpus is a bit more challenging when it comes to the oral form of language, right? So uh, the third point provides an insight into thinking and intelligence. Imagine you interacting, a human being interacting with a robot. You would give a command, the robot would take a command and then act accordingly. It should have some sort of intelligence to understand that command or what the task is all about, right? And uh, when it comes to monitoring or facilitating human interactions with machine, basically it tries to address the issues of troubleshooting. For example, like you are giving some commands, but then it's not functioning properly. Your software has some sort of issues, and you need to rectify those. Even those tasks can be done through a machine aided system. The major goals of linguistics and competitions would be, I mean, there are so many goals, but then I have listed out a few of those just to give an idea. So one of the major goals is to understand like efficient text retrieval on some desired topic. All of us actually use, for example, Google or any such search engine to get some ideas about certain topics. So what do? We open a search engine like say Google, Yahoo. It could be anything. You type your desired topic, and then the system takes the input, goes through all the saved input within the system, and then try to match the strings that has been given as an input and show you the result, right? Second point is effective uh, machine translation. Okay, machine translation itself is a lot complicated system. A lot many things are involved in machine translation. But then, just to give a rough idea to the newcomers into computational linguistics like discipline, you can always type something in your mother tongue or in English and just try to see, and I mean you do it in Google and you try to see like the kind of translation it gives. Now for major languages of the world, you will get some sort of good translation using Google tools. But then, for majority of the languages of the world, the system still is at the developing stage. Um, I think somebody's microphone is on. Can you please mute? Uh, okay, so coming back to the point, you can see if you type something in English and ask for an Arabic translation or VZBs, you will see sort of weird results, right? Question answering refers to the functions where say for example customer cares, there already you have got some frequently asked questions, or imagine you interacting to a service provider, and then they would ask you like to press certain numbers or certain buttons to get your desired answers. So like the simple task can be done by the machine. That's all the idea is. Text summarization. So you have a book of say 1000 pages, you wanted a summary. um, the system can actually give you a summary of that. Analysis of text or spoken language for a topic, sentiment or other psychological attributes. Now, this is very interesting. I will give a very simple example. Uh, all of us do online shopping these days, and you may actually look for a product in an in a site, and then maybe because of some reason you didn't wish to buy that particular product, you left that in a particular site, come back and open your Facebook maybe, and then you will see particularly that particular product would be popping out in your Facebook page somewhere, and then it shows some sort of advertisement about it, right? So, or sentiment analysis can also be understood in the way we give customer care feedback, right? So the companies would actually take those inputs and try to analyze and would try to enhance their service facilities. Dialogue agents for accomplishing particular tasks, for example, purchases, technical troubleshooting, trip planning, schedule maintenance, medical advising, etc. Okay. Ultimately, the main goal of computational linguistics is to create computational systems with human-like competency in dialogue, in acquiring language and gaining knowledge from text. There are many applications. So what is the current trends and the status of Indian languages? So speech technology, say, if you look at the Indian language context or like the scenario, you will see over last 3, 4, or 5 years maybe we have a lot of technological development when it comes to speech technology. We have smart devices starting from say electricity functions, smart rooms. We have Alexa kind of devices. We have many Google tools through which we can navigate through different functions. We have text to speech kind of system, so you can just give commands over your voice. The system will start typing things for you. Or vis-a-vis, you can actually, these things are available in a smartphone even now, right? You have automatic speech recognition system and the way neural network would function. So from that point of view, we can see many of the major Indian languages, actually there are technology developed for many of those developed Indian languages. By developed Indian languages, I mean like the major languages, most of them are part of our official language group. So even if we bring the context of Northeastern languages, a lot of work has been done on Assamese, Bangla, even in Sylheti. Recently there are some speech recognition systems that has been developed for Sylheti as well, and then some work on Mizo and some of other Northeastern languages are also done in, at IIT Guwahati. One of the major challenge or development is also could be seen. Both challenge also development could be seen in terms of corpus development. There are some agencies who are trying to develop speech corpus or written corpus at least for Indian languages. We have considerable amount of written corpus for many major languages like say Telugu, Tamil, so all the Dravidian groups like Kannada, Malayalam, Hindi from Aryan group, Hindi, Bangla, Uriya, even Assamese. Some of the also like the Punjabi. So in Punjabi University, Professor Vishal Goel is trying to develop. Vishal Goel and his team is trying to develop automatic translation system from Punjabi to English, and those are like success stories. So Siddharth Pune, CIL Mysore, then Dr. Ritesh and his team at Agra. So they are actually working on developing many AI service systems. There are many IITs, including say IIT. Also trying to develop those technological tools for like automatic translation systems following like the rhythms by some considerable most of the Western languages, we would see like much of those developments. It is largely because of many factors. One is, ability in general is a major challenge for almost every languages. Another challenge is lack of coordination among the researchers working on different languages. But then these are general problems. The first two, the final two, specific things like problems when it comes to developing technical, computational tools for artificial languages. One of them is most of the development languages are absorbed in so when we talk about languages of communication, obviously we have that specific structure, and we don't have much data. We don't have much data because most of this language again there are many logistic issues collect or let's say develop corpus. Developing speech corpus itself is a challenge, and then there are other logistic issues like sound that can actually help develop such tools for our multi-speech languages. Now, I actually wanted to talk more about the complexity of the structures of our multi-speech languages, but then I thought I might not have enough time, so I'm just skipping that part. Rather, I'm actually trying to make this more relevant interest some about interesting aspects of AI and linguistics. So, I'm trying to connect the biomedical aspects of language production. So we already know that speech production actually requires sort of thinking, right? So and then you actually involve your physiological organs to release the idea, right? So in the process, actually, we also experience some sorts of byproduct fluids like saliva, spittle, sweat, tears, blood. For example, if you are put in a situation where you are very scared, and then you have to speak on something, you actually start sweating. Or say, for example, when you are under pressure or you are in a pain, where you talk, the tears will roll out. I actually, along with my team, we were interested to understand if there is any sort of correlation between these biofluids and the way we produce speech. For example, a considerable amount of spittle is released during the production of speech sounds, especially the plosives, the stops. So, for example, when you produce a lot of spittles actually is released. Now, there are many research going on, especially after this pandemic. It is started understanding the reason behind spreading of such diseases like corona. So basically, the spittles that non-human beings release can be actually observed via microscopy, and then the way they dry them, so kind of things they carry, and then when other person knows distance, so now every day after pandemic, so maintain social distance. Right? Why is it so? Or wearing a mask, because when you speak or when you sneeze, basically you release some sorts of air fluids,
So, to start with, what we did actually, we tried to understand the process of those drying mechanisms. Uh, like, you can have, say, for example, water droplets, or say coffee, like, splitting on your dress, or the like, blood scene, in a crime spot, right? So, like, the function uh, of those droplets, or like the different stages of those droplets when they dry up, can actually reveal a lot of information. At this point, you would actually wonder what is the connection between linguistics and those biological droplets. So, just to give you an idea, look at, like, two of those biological fluids. One is, of course, the blood fluid, and the other one is tear. So, this is the tear of a healthy person, and like, when somebody is down with, say, glaucoma. So the early stage, the developed stage, and then the terminal stages, right? Uh, the blood, like, samples of pneumonia. So, so some patient, when they died of pneumonia, and then, this is the healthy one, and then this is 10 days before death, 2 days before death. You can see, like, the kind of changes those can be observed. Now, to this point, we don't see any linguistics, like, in it, involved in it. Understand is that these are the stages which can be actually, or these are the information which can be incorporated via AI to develop certain algorithms, to develop certain models. I'm trying to, like, explain a bit of the physics involved behind this drying
and droplets. So you can see like this is the initial state of a single drop of human blood, and then when they start drying in an ambient condition, so room temperature condition, so there would be certain cracks. You can see the development of those cracks, and then the analysis of those cracks, the patterns can actually tells us many information about the kind of blood that we are examining. For example, you take the blood of a person suffering from certain diseases, like say cancer patients, say for example patients suffering from diabetes. Vis-a-vis, you compare that these patterns with the droplet of a fully healthy person. So what sort of differences do you see? What we are trying to connect, actually most of these experiments are done by one of the PhD scholars. She just earned her PhD from WPI USA and moved to work moved to UK now to pursue her postdoc, Dr. Anusha Pal. So most of these experiments were done by her. I have a personal collaboration with that particular team where we are trying to understand, the patterns of those biofluids in diseased person and compare those patterns with the samples of a fully healthy person. So what we are trying to do is actually we are trying to create an image data bank, okay, of different stages of such diseases, and try to understand how those patterns keeps on changing during the advanced and the final stages, right? Now, how do I connect linguistics into it? For example, now say for example, if we try to understand why is it difficult for us to produce certain sounds. So of course, you see, okay, after certain stage, our articulators are developed in such a way that we cannot produce those sounds, right? Even if we learn a second language after a certain age, we cannot articulate those sounds just like the native speakers, even after considerable amount of training, right? Now, the question is, if you see certain diseases, like say the patient suffering from cancer, okay, after a certain stage, they start losing their language, or there would be some sort of defects in the way they produce language. Our idea is to see if those things can be linked to detect those sorts of diseases at an early stage. Whenever we suffer from any cold-related problems, like say for example, fever, cold, common cold, or any flu-like symptoms, so the way we produce language and then the way we release those speakers, if we study those things, can those show certain patterns, uniform patterns, which can actually help us to detect, the say for example, the rate of being affected, or the stages, different stages of those diseases, and then if we can actually develop a mechanism to prevent those stages. For example, in case of biomedicals, people do get medicines at different stages. So if we can link, if those particular drugs are actually useful to release, or so to relieve, those particular diseases at a certain stages, we can actually understand the efficiency of that drug, okay, at different stages. Okay, so the moment you suffer to the extreme point, you actually start taking antibiotics, for example, right? To understand at what point do you need to take antibiotics. Okay, if those patterns can give you some sorts of ideas. Basically, this idea is sort of abstract at this point, in the sense that we just started like exploring more ideas. If we can actually develop a model, okay, and that can be used to like detecting those diseases through linguistic functions, right? That would be like really great. Um, some ideas of tears, okay, like the patterns of tears and their different stages. So like this is again one of the biofluids. So the patterns of those tears when somebody is under some sort of grief. Basal tears, the tears that you regularly keeps on, I mean, that we regularly keeps on releasing to keep our eyes clean, and the tears that we get while cutting an onion. You can see like these complexities, like the complexities patterns. Now let us try to understand some of the neurological disorders. For example, stroke. Okay, so you get a stroke and then your language is affected, right? You have Parkinson's disease, autism, aphasia, dementia. There are many such neurological diseases. Okay, and then these, like some of those biofluids actually can help us to understand uh, different stages of those diseases, and possibly also in future like help us to prevent those diseases. How? Okay, uh, for example, if we can imagine preparing a sort of device. Now we have certain device that can easily detect the sugar level. So what does it do, or how does it function? It takes the you just drop one droplet of blood into the strip, and it actually tracks start calculating the amount of blood into that droplets, and it gives you a results, tentative results. Now imagine if we can develop that algorithm, the model of those diseases, that is different stages of those diseases, and develop a biosensor or a device that can be actually used as a desktop machine, the small device that can also tell us or indicate us if we are at the risk of developing certain diseases of those types, wherever we can connect some of those neurological diseases, right? So uh, I just wanted to show you one of the major functions of AI. So uh, actually we can connect a lot of such things through computational modeling. Okay, here we are more interested in developing computational tools that can actually develop or that can be actually attributed to detecting and function as a solution to many such diseases. Thank you. Uh, I think I have finished within time. You may ask questions now.
Thank you. Thank you very much, Amalesh, for your very wonderful and insightful presentation on the aspects of AI and image processing in terms of computational linguistics. I'm sure these are things which are very new to some, and some are quite familiar. So the room is open for discussion. We have 10 minutes. If you have any questions, you can unmute and ask, or you can put it in the chat box. Yeah, please.
Please ask questions, because this is something very new, possibly I just wanted to trigger some sorts of interest, actually, especially those who are considering to pursue their research, future research through AI or computational linguistics. No, this is something really exciting you can also think about. There are a lot of work actually going on from cognitive and like say neurological point of view, even in some of the Indian institutions, okay, in some major medical situations where people are trying to understand the link between linguistics and those neurological diseases. Okay, so you can actually read more about those things. Nimans, there is a group in Nimans who are actually working on understanding the correlation between linguistics and dementia. So you can actually just type those things in Google and read more about those research.
Yeah, and Amalesh, maybe you can text your contact mail ID so that the students can communicate if there's anything they want to discuss with you in the near future.
Sure.
Right.
I don't know how much justice I did to the like the first year, first semester or third semester students who actually start exploring computational linguistics. I actually tried to trigger more research interest into this field. And for your information, I would also like to inform you that we are also trying to develop some computational tools, like for the sign language users. This project is headed by Professor Vishal Goel of Punjab University, and we are trying to incorporate like all the official languages. Uh, very soon it will be like released for public uses. So that's a like kind of social project that we have those signs in their own language. So, for example, using Assamese, using Bangla, using Hindi, using Punjabi, and all. So, you type something, and then the signs would be shown using an avatar. So, for example, you wanted to show "I'm happy now," and then the avatar will actually show you those signs. You can write those sentences in your own language, and then you will get response. You see, in a recent development, even Flipkart. Okay, if you have observed it, try to incorporate many Indian languages in their website. What is the need actually? The need is to get more closer to the like customer, to the buyer, right? To understand. So a lot of applications can be, or a lot of like things can be achieved through AI, and that's the things we should look forward.
Yeah, right. And I also remember like Amos Teo, being a linguist, he's also working with Amazon, basically for the same purpose which Amalesh has given for AI. So there's quite a lot of scope actually when one specializes in computational linguistics. So please feel free to communicate with Dr. Amalesh Gope, and he's very open to his students. Those who are here, they know him very well, and he's very open and frank and is always helpful. So please feel free. And not only computational linguistics, his area of expertise, in fact, is many. I might have missed mentioning it at the beginning of the introduction. He also specializes in acoustic phonetics, in phonology, in OT, in he has also done experimental phonology and cognitive linguistics. So he has quite a lot of experiences in all of these applied linguistics, even psycho and neurolinguistics. So basically, he has so much to share, but because of time constraint and because of the topic, so he could come up only with AI. So I think there will be questions. Okay, there is a question by Sharmishta. I think Amalesh, you can see the question. Okay.
What do you mean by ADHD, Sharmishta?
You can unmute yourself, Sharmishta.
Sir, it means attention deficiency disorder.
Oh, okay, okay, got it. There are some work actually going on. The problem is actually, you see, we do not link well in the sense that a complete team is required. People from pharmaceutical areas, those who are working in specifically biological or cognitive or say neurological aspects. People from physics. Some sorts of work is going on. Now our team is relatively new. Okay. And we are trying to basically stick ourselves to diseases like cancer, like sugar, and some sorts of dementia as of now. I'm sure there must be some work going on ADHD as well, but I'm not very aware of it. Many pharmaceutical companies are now trying to take the help of AI to understand the usefulness of those drugs at different stages. Okay, and then if you can see the patterns, before or after using those drugs, and compare those things with different stages, we actually get to know the usefulness of those particular drugs on a particular stage. Thank you for asking that question. I'll inquire about more about it, and then I'll get back to you.
Okay, thank you, sir.
Yes.
Thank you, Samishta, for the question. And are there any more questions? It's all right if you think it's wrong, you can still ask.
Yes.
There's no problem in it.
Please to ask.
Nisha, would you like to ask a question? Nisha or Nishi?
The first semester students, the ones who are doing computational linguistics for the first time, should have a lot of queries actually.
Lorena, do you want to ask any question?
Oh, I can see Mary. Hello, Mary. How are you doing?
Oh, she joined.
I could see her.
Okay.
Okay, if there is no question, that is okay. You can still write to me if you have anything to know more about this particular field. I'll be very happy to share whatever I know or whatever research that has been done so far. Okay.
For helping in making the students and the scholars get a view of the AI image processing in relation to computational linguistics. Participants have learned something new. Okay, it's great. There's one, I think, query in the chat box. Siransh Agarwal.
Yes, that's what we expect actually, right? That's what we expect. Now, at different stages, even the degrees of gift can be linked to the drawing, through the drawing process. That is to say, if you are suffering from a very sorts of high loss, and then then you release tears. Basically, it's you are releasing tears because you had been beaten by somebody. Okay, you lost something, that's why you are crying. You are beaten by somebody, that's why you are crying. Or maybe you are crying out of happiness. All those things should be showing different patterns basically, right? So that's the interesting part, right? That you can link it. What stage the person is in, or even if sweat actually is the sweat because of heat, or is it because you are in super tension. Okay, if you if you try to understand now the stage of stroke, when do people get stroke? When the pressure rises, right? So you are extreme pressure. You because of this extreme pressure, you have a rush of your blood circulation to your brain, and then suddenly there is a blast kind of thing. So you lose your consciousness, right? We expect different patterns or different sorts of drawing process involved in different stages of TS. Yes.
Thank you for the question. And thank you again. If Dhiren Singh Asar is there, then may I request you to say brief words to give vote of thanks. Dhiren sir, yeah.
So thank you Dr. Amalesh for a wonderful and insightful presentation. I hope that today's show will give more interest and more, eager to learn linguistics among our students. And I hope all the students linguistics. And I just request Amalesh Group, if we invite the next time, you please accept our invitation for the talk. And I'm really thankful to all the students talk. And I wish all the best. And you please have a great.
Thank you always. I mean, today I just tried to show and share some of my recent work of our team. I'm sure, Professor Indranil Datta, who's the next speaker, he would be sharing, more insights. So I just, tried to do traditional class kind of things and try to share some of the research, that people can think about, especially the young researchers who will be entering into PhDs and their research work. Dr. Ritesh is also working tools. There are many actually, currently working to develop tools for Indian English. So I'm sure, you will have a very fruitful journey to us. And I wish all the students, all the participants, all the best. And please do write to me if you have any queries. Thank you, Monali. Thank you, opportunity to share my ideas with you all.
Thank you, Amalesh. Thank you, everyone, and see you next week. Bye.
Thank you, everyone.